Hello students, welcome to my YouTube channel. We are doing a series of lectures in which we are solving all VOR, RMI and ADF questions from RK Bali. Very important questions from exam point of view and also for practical flying experience. So far we have done many questions. Now we will start with the next questions which are remaining. Question number 21, starting with question number 21, question 22, question 23, so on and so forth. So to do these questions, always know the theory, how your system works. And also as we solve these questions, I will be starting from the scratch. I will explain the VR working, the possibilities as if you're doing it for the first time. So let's begin today with our question first, which will be question 21 from RK Bani. Aircraft heading is 041 at 17.5 miles from VOR. Aircraft is on a magnetic bearing of 215 from. So this is magnetic bearing from the station, which will be your QDR. They are talking about your QDR. OBS is 212. VOR and NDB are co-located. You have to find relative bearing and RMI indication. You have to find to and from indication. You have to find CDI indications. You have to find CDI indications. So let's start. Aircraft heading is 041. That's fine. Aircraft is on a magnetic bearing of 215 from VOR. So that means it is on a magnetic bearing of 215 from VOR. QDR is 215. In other words, they are trying to tell you that you are on a radial of 215 from the VOR. 215 from the VOR. OBS selection is 212. But so currently you are on radial 215. Let's say somewhere here. Okay, we will see if we are approaching to the station or flying away from it. But before that, the OBS selection is 212. OBS selection is 212. Right? Aircraft heading is 041. Before that, whenever you draw QDR, always draw the reciprocal of that, which is QDM, and it will be equal to 215 minus 180, 215 minus 180, 035, 035. Okay. Now, OBS selector is set to radial 212. So, 212 will be somewhere here, less than 215, that therefore to the left of 215. So, radial 212. The opposite of radial 212 is 032. Radial 032. Next, you are flying at a heading of 041. So heading of 041 will take you towards VOR NDB station, not away from it. Okay, 041, a heading of 041 will take you towards the NDB station. So that means your aircraft is pointing somewhere that way, which will be 041 direction. Okay, so 35 is this, so 41 will be to the right of it, somewhere that way. So now aircraft is traveling on radial 215. It is approaching the VOR station. Okay, we have reciprocal of 215, which is 035. This is the complete diagram: 215, 212, 032 and 035. Heading is 041. Now in the OBS selector we have put a bearing of 212. We have put a bearing of 212. So with this, the CDI needle will show what? Now 212 is to the left hand side. 212 is to the left hand side of what? It is to the left hand side of 215, right? All the radials, the work of all your radials is to take you away from the station, take you away from the station. So if you have put radial 212, okay, which is to this side of the station, and the radials which will take you towards the station are 032 and 035. But the pilot has put radial 212. So the indication in the to from will be definitely from indication, and since 212 is to the left of 215, you will be getting a CDI indication of fly left. Irrespective of your aircraft heading, the VOR system is concerned about your position. The VOR system detects that you are currently on radial 215. The pilot he detects, then the VOR detects, it detects that you have put radial 212. So with respect to 215, the radial 212 going outbound. Okay, so the perspective is left and right. Going outbound, the left side will be here. This will be your left side. This will be your right side. Going inbound, this will be your left side and this will be your right side. So now when we have put radial 212, so it is definitely talking about outbound radial, okay, outbound bearing. So that's why the CDI needle will move left, telling you that radial 212 is currently to the left of your current radial 215. So that's why the CDI needle will move to the left hand side. It will move to the left hand side. The to and from indication will show from indication. So this is the answer to the question. To and from shows from. CDI needle will move left. Now how many dots left? One dot equals to 2 degree in case of VOR. Now the difference between 215 and 212 is, the angular difference is 3 degree. The angular difference is 3 degree. So one dot is 2 degree. So 3 degree will be equal to how many dots? It will be equal to 1.5 dot. So the CDI needle will move 1.5 dots to the left. Okay, 1.5 dots to the left. Next, what is your relative bearing and RMI indication? Now relative bearing and RMI indication. QDR is how much? Currently the QDR is 215. QDR is 215. QDM will be how much? 215 minus 180, which is 035 degree. Now QDM formula is magnetic heading plus relative bearing. So 035 magnetic heading is how much? 041. Relative bearing we will find out. So relative bearing will be 035 minus 041 minus 006 or minus 006 or add 360 to that, it will be 354 degrees. It will be 354 degrees. So this is how you do this sum. So 354 degrees your relative bearing. RMI is 035 degree. So these are the answers. So starting with the first step, draw VOR and DB, both are co-located. Draw the QDR, draw its direct reciprocal QDM. Same. Then we proceed to the next information, which is OBS selector 212. We have drawn its reciprocal radial 032. After that, we drew the aircraft with a heading of 041. Now this heading is irrelevant to your VOR sum, but it is relevant to finding relative bearing. So we will keep this information reserved when we go there or when we reach that part of the sum. Now, as for VOR, they have not stated that we are going towards or away from the station. The only information that we have is we are currently on radial 215. We have put radial 212. So whatever to from indication or CDI indications will be with respect to these two radials. Now radial 215 will take you away outbound, radial 212 will do likewise. Okay, so these radials are meant to take you away from a station. So the to from indication will show from. And since 2 radial is to the left of radial 215, the CDI needle will move 1.5 dot left, where 1 dot equals to 2 degrees. Also, when flying outbound, the perspective is important. When flying outbound, this will be your right side. When flying inbound, this will be your left side. Same goes with this side and this side. So that another thing you have to remember. Next, to find relative bearing, you were given in the question QDR. From that you derived QDM. You use the formula, which is magnetic bearing to the station, made of two parts. It is made of your heading and the relative bearing between your heading and the track towards the station. Now diagrammatically, how will you represent this? This is your NDB. Okay. The track to the station is QDM, which is 035, which is 035 degrees. Next, magnetic heading is 041. Magnetic heading is 041. So if this is 035, this will be 041. So aircraft pointing a little bit to the right of 035, which is 041. And track towards the station is 035. So now the relative bearing is the angular difference between your aircraft heading and the track towards the station. And you have to always measure all directions or angles in clockwise direction starting from the heading in case of relative bearing. So this will be your relative bearing starting from here, ending here. Now this entire circle would have made and will a 360 degree, but we have not made a full circle. We have stopped less of that. So the relative bearing will be the entire 360 degree minus this small angular difference which we have eliminated. So this part is equal to an angular difference of 0.006 degree, right? The difference between 41 and 35. So relative bearing finally will be 360 minus 0.006, which is equal to 354 degree. 354 degree clockwise, or can also be interpreted minus 6 degrees anti-clockwise. Okay, that means the station is minus 6 degree to your left hand side or positive plus 356 degree to your right hand side. Let's go to next question. RMI is 170. Aircraft heading is 030. Find ADF reading. Now, the case with RMI. What is RMI? RMI is a combination of magnetic compass, next VOR system, next ADF, automatic direction finding, or NDB system. These three components make one RMI. So let's draw this RMI indicator like this. Okay. So over here we have the magnetic heading represented to you. So whatever aircraft heading the heading aircraft is flying, that heading will be represented here the same way it is done in the magnetic compass, right? Next, we have two needles, one for VOR, another for NDB ADF system. So one needle, let's say this, the needle which is filled with color will be your VOR needle. Okay, the one filled with color will be your VOR needle. Next, I am drawing another needle which is same needle but a hollow needle. That means I am not filling this needle with any color. Okay, so let's label this. This is where your magnetic heading is represented, your compass heading. The head of this VOR needle is your QDM. The tail of this VOR needle is your QDR from the station, VOR station. Similarly, the head of this needle, that is will be your QDM towards the NDB station, QDM towards the NDB station, and the tail of this needle will be, tail of ADF will be representing QDR, that is magnetic bearing from the NDB station. Okay, so this is the information given by RMI. Next, RMI only deals with QDM. So that means this instrument will directly give you the information of magnetic bearing that you're supposed to fly to go towards your station. Indirectly, it gives you QDM, direct information. Only in just relative bearing indicator, simple relative bearing indicator will give you the information of relative bearing, the angular difference between your aircraft heading and the track. From that relative bearing, we always derive QDM, magnetic bearing to the station. Contrary to that, RMI instrument directly supplies to you the QDM information. You need not find relative bearing. In such manner, it relieves the pilot of his workload. Okay. Next thing, in exam, whenever RMI question is there, an ADF word is used. Okay. So RMI ADF. So the RMI always deals with QDMs. ADF will be your relative bearing. So let's use this formula. Now RMI, nothing but your QDM is equal to magnetic heading plus relative bearing. Substitute the values. QDM is 170, heading is 30, relative bearing. Relative bearing will be 140 degrees. Relative bearing will be 140 degrees. Let's draw this. Let's say this is your NDB station. The QDM to the NDB station is 170. Okay. So QDM to the NDB station is 170. Considering this is your north datum, so 170 will be your QDM. QDR will be 350. Okay. Aircraft is heading 030, is heading 030. So the track QDR away from the station is 350. Towards the station is this, which is QDM 170. Now relative bearing is the angular difference between your aircraft heading and your QDM measured clockwise. Measured clockwise. Okay. So measure clockwise. So QDM is 170 and this is 030. So the angular difference between them is 140. So that means the NDB station is at a relative bearing of 140 from your aircraft heading or from the longitudinal axis of your aircraft. Next, relative bearing, also known as ADF reading, automatic direction finding, finder equipment reading. Let's go to next question. Aircraft is flying to station with 15 degrees starboard drift. RMI shows 090, OBS selector is 260, variation is 15 west. Okay, find VOR information, QDM and QTE. So fine, easy question, it looks difficult. So aircraft is flying towards a station. So this is one hint given to us, that is approaching the station. 15 degrees starboard drift and RMI showing 090. So RMI is nothing but RQDM, which is 090. Next information is starboard drift. Now whenever there is starboard drift, in case of starboard drift, your heading is always less than the track you are flying. For port drift, your heading will be more than the track you are flying. So starboard drift is 15 degree. Okay, heading will be less than track. We will see that. OBS selection is 260. So your QDR 270, QDM track towards the station is 090. So currently the information given to us is that RMI, which is QDM, directly to the station is 090. Directly 090. And next OBS selection is 260. Another QDR or another radial 260. Okay. So aircraft is what is CDI. So currently I'm writing here, currently aircraft is on radial 270. Currently the aircraft is on radial 270. Okay, and that's why we have RMI indication of 090, right? You are on radial 270, radial 270 takes you away, and QDM, which will take you towards the station, will be 090. So you will get radial or QDM 090 only and only when you are on QDR 270. Now the OBS selector is put to 260 heading or 260 setting. Now you are flying towards the station. You are flying towards the station. Okay. So there are two cases I want to explain to you. This is your VOR. This is a radial 090. Now on this radial 090, you can either fly away from VOR station or you can fly towards the VOR station. That means on this road or on this radial 090, you can follow this radial and go outbound or come inbound or homebound. So let's say we are going outbound. We are going outbound. We are going outbound from VOR. The settings in the OBS will be 090. You will have to put in the OBS selector. Therefore, you will get prom indication, and the CDI needle will remain in the center. Will remain in the center. Okay. CDI needle will remain in the center. Now, another case. This is your VOR. This is your radial 090. Again, you are flying towards the VOR station. Now, in this case, you are flying towards, not away from the towards the VOR station. So in this case, what will you do? In your OBS selector, to get a normal sensing, in your OBS setting, you will have to put 270, 270, the reciprocal of radial 090, 270. When you put 270, you will get two indication, and that is your purpose of flight, that you want to go towards the VOR station or inbound. The CDI needle will stay in the center. If you are correctly established on the center line of the radial, the CDI needle will remain in the center properly. Now what happens? This is called normal sensing. This is what you should normally do at every flight. Okay. So at normal sensing, what is the significance of that? If aeroplane, while going towards the VOR, it gets drifted to the right hand side. If it gets drifted to the right hand side, CDI needle, the CDI needle as a result of that will move to the left hand side, saying that the 270 indicate bearing is to the left of your current position. If aircraft gets drifted to the right left hand side, from here the left hand side will be this side. So this will be its right hand side. Approaching VOR station, this will be right hand side. This will be left hand side. Now if it gets drifted to the left hand side, somewhere here, the CDI indication will move. The CDI indicator needle will move to the right hand side like this, telling the pilot that your 270 bearing is to your right hand side, which is nothing but 090270 to your right hand side. So you have turn your aircraft heading to the right, intercept that radial 0900 and fly homebound VOR. Okay, that is how you follow the CDI indications. Now it is called normal sensing because if the CDI goes left, you go left. If the CDI goes right, you go right. Now the another possibility is of reverse sensing. Now in reverse sensing, what happens? Although although you're going towards the VOR on radial 0900, the pilot selects in his OBS setting a number, a bearing of 0900, a bearing of 0900. Now this bearing 0900 or QDR 0900, radial 0900 intends to take any aircraft away from the VOR station, away from the VOR station. But in this example, you want to fly towards the VOR station. So in spite of that, okay, in spite of flying towards the VOR station, if you put a bearing of 0900 instead of 270, all your indications of CDI, force deviation indicator, will be with respect to the 0900 radial and not with respect to the 270 radial or QDM 270. If you are flying inbound, you are concerned about QDM 270. If you are flying outbound, then and only then it will be proper to put 0900 in the OBS selector. You are flying inbound, but you have put the setting or given an input of radial that is going to take you outbound. So that means there is some mismatch, right? So your expectations and the inputs that you have given are not matching. So in this case, the CDI will give you reverse sensing. Meaning what? Previously I told you when flying inbound, this was your right hand side, this was your left hand side, correct? But flying outbound, this will be your left hand side, this will be your right hand side. Flying outbound, that will be your left, this will be your right. Flying inbound, this will be your right hand side, this will be your left hand side. Now the OBS or the VOR equipment in your aircraft doesn't know the heading of aircraft, whether it is flying towards the station or away from the station. All it is concerned about is your aircraft position. So whatever position or input you put in this selector, OBS selector, according to that the CDI needle and the two from indicator will behave. Okay, so if you put 0900, so that means the VOR equipment in your aircraft comes to know that aircraft is situated on, it already knows it is on 090, plus it gets the information that you intend to fly on this radial and go outbound. So accordingly the information will be supplied to you. So if you put 090 radial, you will get a from indication and the CDI needle indication will be according to that. Let's say you have deviated to this side. Approaching your station, you are deviated to the right hand side, but you have put radial 0900 in the OBS selector. So instead of getting instead of getting a left CDI indication, which is what you should get, because if you get drifted to the right hand side, you have to get a left hand indication, a solution which involves a turning to the left hand side or a left turn. But you have not put 270, you have put 090. So that means according to 090 radial going outbound, if you are on this side, okay, if you are somewhere on this side, the CDI needle will the CDI needle will get the information that aircraft is to the left of 090, and therefore it has to come to the right hand side so that it comes back to its original course or original track. Okay, so this is what reverse sensing is, the reverse of normal or the opposite of normal. Okay, so you're tracking towards the station, okay, and you have drifted to that side, okay, above this 090 radial. Above 090 radial, this side will be right with respect to homebound, and the same side will be left with respect to outbound. Now it depends. The CDI will behave according to the input given. You have put outbound number, which is 090. So according to outbound, you have drifted left hand side. The solution will be to fly right hand side or to turn your aircraft right so as to come back to your original course. Okay, so CDI will move right hand side. Next, so what will pilot do? The pilot, what he does? He does not follow. He does not follow the CDI needle. In case of reverse sensing, you don't have to follow the CDI needle. In case of normal sensing, you do what the CDI needle tells you to do. But in reverse sensing, you do the opposite of that. So the CDI needle has moved to the right hand side. So what will you do opposite of that, which is left hand side? So you will turn your aircraft left and come back to radial 090, and after coming back to radial 090, you fly towards the VOR. If you don't do that, and if your this conceptual understanding is weak, you will erroneously follow the CDI indication and you will go right hand side. When you go right hand side, you will not come back to your original course, but you will again go somewhere farther than this current position. You will go even farther than that, somewhere here, and you will keep going farther and farther in the hopes of centering the CDI needle, which will not happen because your understanding is weak or you have interpreted this instrument in a wrong manner. Okay, so in case of reverse sensing, this is what happens. So the correct way always is that if you are flying outbound, then and only then put radial 090. If you are flying inbound like here on radial 090, you put the reciprocal of that, which is 270. Then you will get the proper sensing and proper information. Okay, and it will relieve your workload heavily. So this is what is the manner. Now this I have taken very simple numbers 090, but the logic applies to all other numbers, all other directions as well. Now let's come back to this question in which we were given that you are flying towards the station, okay, and you are currently located on radial 270. So our aircraft is on radial 270. We have to go towards the station. So our OBS selector should have been, you should have put radial 090 here, okay, because you are on radial 270. But if you put radial 270, you are expected to fly outbound. You have to fly inbound as given in the question. So the correct way is to put the reciprocal of 270, which is 090, which will take you towards the VOR and give you a correct sensing, normal sensing. So you will get two indications shown here, and the CDI needle will have to remain in the center if you are flying, if you are correctly established on 270 radial. Okay, but this is what should happen. The question states that the pilot, instead of doing this, has put has put 260 has put 260 radial in the OBS selector. Right? So what will happen? You want to go towards the VOR station, but you have put a radial information which is intended to take you away from the VOR station. So what will happen? What will the CDI needle do? It will show from indication because radial 270 takes you away from VOR. Radial 260 will take you away from the VOR. Next, the CDI indication. Now the CDI indication will work according to the input you have given, like we have just seen in the previous example which I explained. So 260 is to the left hand side of 270, to the left hand side of 270, because going outbound, this will be your left hand side, this will be your right hand side. Okay, and all radials take you outside, outbound from VOR. So there is only one perspective. So 260 is to the left, and therefore the CDI needle will go to the left hand side. The CDI needle will go to the left hand side, telling you that the pilot should turn his aircraft to the left. Okay, so this is the answer. So CDI needle left, to from indication will show from. And what kind of sensing is this? Is this a normal sensing or a reverse sensing? It is a reverse sensing. This will be your reverse sensing. Why reverse sensing? Because it's given in the question. It's given in the question that you have to fly towards the station. If you have to fly towards the station, the correct solution would have been either to put 090 in the OBS selector so you transition easily from 270 to 090. Fly 270 radial, overfly VOR, and then switch over to radial 090. So the two indication here after overflying VOR will automatically become from indication. Or another important or another possibility could have been, like the pilot has put 260 over here, instead of doing that, he could have put the reciprocal of 260 or any other number which is in the neighborhood of proximity of radial 090 if he wants not to cross 090 but some other radial. So 260 opposite is 080. So 080 with 080, he would have gotten two indication again, because that is towards the VOR station. Even that heading is towards the VOR station. But the CDI indication will not remain in the center like here, because you are currently on 270, which is 270090, right? And you have put OBS selector 0, you have put radial 080, and you are going towards the VOR station. Going towards the VOR station. Now 080 when going towards the VOR station is to the left hand side of 090. When going towards, this is your left, this is your right. So your CDI needle will move to the right hand side. To the right hand side. Why right hand side? Because 080 is the reciprocal of 260. So your aircraft will have to turn right, will have to turn right and fly along this radial 260 towards the VOR. When it does that, it will overfly the VOR and automatically find itself on radial 080 going away from the VOR. That's why we have put 080. So this is how such sums are done. With practice, you will get comfortable. Okay. So with radial 080, you are currently on radial 270090. You have put 080. Okay. So to go to 080, you will have to make a right turn on 260 and then fly 260 to go on 090. Now this entire picture is the top view. Is the top view. That means you are looking at all this scene from top, from the north pole, from the top position. Okay, and this is how it will look. So it is first from indication given by the CDI, left indication, and then this will be a reverse sensing, because you are going towards the station but the inputs that you have given in the OBS are for outbound setting. Next, what is QDM? QDM is magnetic bearing to the station. So magnetic bearing to the station is directly given to you RMI, which is 090. That is nothing but your QDM. What is QTE? So QDM is 090, magnetic bearing to the station. Magnetic bearing from the station will be reciprocal of that. We call it QDR. Next, this is magnetic. Now, true bearing to the station is called QUJ, which will be 090 plus minus variation. The variation is 15 degree west. 15 degree west. So, variation west, magnetic will be west. Variation west, magnetic will be best, meaning magnetic direction will be more than true direction. So now we have to find true direction. QUJ is true bearing towards the station. So it will be definitely less than magnetic bearing to the station. That's why I subtracted 90 minus 15, which is 075 degree. QTE will be reciprocal of QUJ, which is 075 plus 180, 155 degree, which will be 7, which will be 255 degree. Okay, so this is the entire solution for this sum. With this question, we come to the end of this particular lecture. Uh, don't miss the next lectures in which I continue to solve the next questions which are remaining. I hope you have understood this lecture. You have understood the concept behind every solution. That is even more important as you progress from CPL to ATPL, airlines, so on and so forth. And now you're getting comfortable in solving questions of this type. Solving UR, ADF, RMI questions requires lots of practice, strong grip or grasp over the concept, the theory also. So even if you are comfortable now, don't leave this habit of practicing such questions. Look for these questions from every resource, whether it's Oxford, RK Bali, Keith Williams, any other book or notes you find from elsewhere. So keep practicing those questions. More and more practice will make you confident and perfect. So if you have liked this lecture, hit the like button, subscribe to this channel if you haven't, and share this video with all your friends. Thank you. Keep learning.